So we're doing partial fractions case 3. I'm going to have something, a linear factor and a non-factorable quadratic factor. So I'm nice. I'm just going to jump right to a problem here. Oh, sorry. I'm just trying not to improvise too much so I don't give you some horrible problem that can't be solved. There we go, sorry. Oh yeah, here's one of my favorites. X squared plus 2 over x cubed minus 1 dx. So I've tried a bunch of things, right? I've tried u sub downstairs, and I could get half of it, but I couldn't finish the problem. So I'm thinking, since that downstairs factors, this is partial fractions. So I tried something else, it didn't work. But then I realized it's factorable, I'm going partial fractions. This is what, x minus 1 times x squared plus x plus 1, right? Of course, after you factor, you probably want to double check it, right? So x squared plus 2 over x cubed minus 1 is some constant over my linear plus some linear over my quadratic. I'm assuming I've got my fractions completely reduced, right? You agree with me, right? Like if a was x minus 1, well then that fraction is really just x minus 1 over itself, that's 1. If a was 2x minus 1 over x minus 1, then I would get 2 plus, right? I could reduce. So I'm assuming everything is reduced completely. So over a linear, I have to have a constant. Over a quadratic, I have to have a linear. Best case scenario, worst case scenario, right? It could be less than that. So b could be 0 in this case. Okay, yes, you with me? All right, what do we do? Don't use red. What do we do? Multiply through by the LCD, right? And then a bunch of things will cancel on purpose. And then I'm going to try and rewrite nice and neat. I'm taking my time. I'm not in a rush. I like to say I'm Polish, not Russian. Even if I was Russian, it's still pretty funny. I'm Russian, but I'm not Russian. Right? Trying to take my time here. Now you see, the process is going to be a little bit more complicated than before, where I just plugged in 2 and minus 2. Here I'm going to have to, well, there's one good value to pick, right? There's one easy value to pick. And then the other two values I pick are going to, I want to be smart about it. So what value do you see that I should pick here? That clears a lot of stuff out. One, right? If I pick x as 1, bx plus c is gone, right? Everything over on the right-hand side is gone. So I get 1 squared. So let x equal 1. 1 squared plus 2 equals a times 1 squared plus 1 plus 1. So a is 1. Nice. What do you think? What else? Who's got a good value to pick? What? 2? Sure, 2. 2's fine. I like 0. I like 2. Probably negative 1 is okay. I'm gonna go with 0 though, because it's gonna clear most of the things out that I don't want, right? So 0 squared plus 2 equals a times 0 squared plus 0 plus 1 plus b times 0 plus c times 0 minus 1. So I'm just trying to be as precise as I can, trying to stay organized. Don't save paper, right? Nice and neat, double checking yourself. So C is, because I know A already, right? A is 1. So C must be negative 1. For the last one, anything is fine. 2 is 7 is fine. It doesn't matter. So, but you got to pick something because I still have to find B, right? So let's do let x equal 2. Usually about this point, I start getting bored. And what I do is I rewrite my generator. I call this guy the generator. It's generating for values of x. It's finding me a, b, and c. So I want to rewrite my generator first. I get x squared plus 2 equals x squared plus x plus 1. Because remember, a is 1 plus bx minus 1 times x minus 1. So you see here, I'm just redoing my whole piece, right? Those x squares are going to cancel. I'm just trying to simplify as much as I can here, right? So my new generator is 2 equals x plus 1 plus bx minus 1 times x minus 1. That's what I'm going to use to generate the value of b when I pick x equals 2. What do you know? B is 0. case 4 gets really, really nasty. So that's why I don't put case 4 in. Okay, so look at what I have. We're almost done today. I've got the integral of x squared plus 2 all over x cubed minus 1 with respect to x is now equal to a over x minus, right? I had 1 over x minus 1 plus 0x minus 1 over x squared plus x plus 1. So, say again. One more time. This is case 3 still. Yeah. That integral is easy. This one, not so much. So what's that first integral? You should be able to see that instantly. ln of absolute value of x minus 1, right? The other one is not so easy. It's an arctan. So let me just focus on hashtag here. I'm going to complete the square. What don't I like there for my arctan? The 3/4. We did some of these yesterday, so Teddy, I'm just kind of doing it blindly because I tortured everybody yesterday with this completing the square piece. And of course, it can be a little bit nicer. I mean, I could just keep going forever with this thing, but got to stop somewhere. I'll stop there.